Go. All right. So just with marine geometry, obviously, you a lot of you poor souls get your geometry from Rhino. So right at this point, with 2306 and above, we can read Rhino geometry. So I was just going to read in a piece that these guys sent me. I think they might have actually gotten it from you guys over there. Just so I mean, I don't know if it's really going to show you anything, but just the whole point here is just to kind of show you that that we now read Rhino geometry. It does take a bit. Well, it's relatively complex, but it's basically just turning your Rhino geometry into parasolid geometry. I didn't even look at this once it came in, to tell you the truth. I mean, I just tried to check it against something else, and I tried to read it into NX, SimCenter 3D, and they don't have it. They don't have a translator to read it in yet. So yeah. So yeah. So there you go. Okay. So there you go. So that we got it.
Now.
Yes. Yeah. So I mean, yeah, you can mid-surface. You can do anything you want. Now, one thing I'm just wondering is, I mean, does everybody know that you can just do this in Femap? This is more for the curved center line thing. I just want to make sure. I mean, just everybody in the room knows you can do this. Okay. Basically, just take this guy. Just pick a bunch of these beams, whatever we might want. And it just automatically made me. Yeah. Yeah. Okay. Let's do hide. Let's do previous. Then it just automatically made me those curves, and then and it also automatically assigned me those cross sections. So it made me all the properties I need, and then it assigned those cross sections as mesh attributes to those lineups. What was that?
When was that introduced?
11.4.2 or 12. Or I think 12. 12.
We have APIs that do that.
Oh no. Well, yeah, no. I think we made an API to do it, but then Mark took that to a whole different level and added that for version 12. So it's, I mean, so like the last 5-6 years.
Yeah. We've been introducing the API because we weren't aware of the little button.
Okay. Well, yeah. So it's,
why we're showing it.
so yeah. So there you go. Curved center line. And it does have a couple of options too. I mean, you can pick a material. You only, if the geometry already has attributes, it'll just use what the material was from each one. You can just have it apply this to all the geometry. You can also have it, if you just want to have it do curves instead, you can do that. If you only wanted to do tubes, like you're just pure piping, you have some options in here as well. So that's, these are all things that you can do. And what it's creating here, unless you have a circle or a tube, it's creating you a general section beam. So that's just something to remember.
Did it create a property?
Yes, automatically created property. Oh yeah, here, we'll just do, well, yeah, here. I mean, I can do that, sure. Geometry curves. These. Oh, there you go. And they were all turned on, basically your thicknesses. And they were all, no, it's not trying to make a plate mesh. It's making general section beam meshes. But it also does take into account all shear center offsets, everything like that you need to get it properly in the same place as where the solid was. So that's again, yes. Oh, I'm glad I mentioned it. Just because it sounds like some folks actually did not know about it. Sure, go ahead. Oh, sorry. Well, these things happen. So just, but okay. So yeah, but you can do it now. Now, just realize that if these things are not connected, you still might need to do some connection between these various, the elements at certain places at the nodes. Just go from node to node of the other one and that sort of thing. But if you had something a little bit more, well, not a little bit more complicated. I was really just going to kind of show you one of the ones that I typically use here. Where am I going here? Sorry. I didn't have it because I wasn't exactly expecting to show that, but okay. Oh. Well, yeah. Totally tubular. Totally tubular is a good one. Yeah, I mean, this one just works flat out. I mean, you just basically pick it, give it this. It's literally just you pick the one thing. It's done that quick. Mesh. Oops. I wanna hide that guy, and then mesh these guys. Just the ones that are visible. Also, I hope everybody knows about visible now. And then thickness.
When did that come in?
It's the same command.
No,
Visible.
I've
Oh.
been using.
Visible came in.
But I don't think I started using it when it came out.
I want to say 2019. Yeah. So it was for Femap 2019. I mean, honestly, a lot of stuff I was going to talk about with tips and tricks was going to be from 2019 on, just because a lot of people went to 12 and then stuck with 12, and I found myself doing demos for 5 years worth of Femap stuff that they had no idea, that people asked for a long time, that no one really seems to know about.
I actually don't think I started using it.
Yeah.
When it came out.
Yeah, it comes in real handy, and then along with visible though, I mean, there's also like let's just do list model elements. There's also even ways to do this where you can turn on select visible only, and then it changes all these by color, by model data. Basically, so then it basically is already one level down based on what's visible, and then by color, and then by model property data or whatever it might be. So yeah, so just basically, yeah, you could do that. And while I'm sitting, while I'm sitting here in this tool, I mean, let's just remember, because Andrew showed it, coordinate, around point, around vector, around plane picking. These are all wonderful things. They're very, they're very, very helpful. This was one of these ones where I was at a training class and somebody said they had it in Patreon. I came home and we had it by the end of the week. All this picking. So but that was a long time ago. So just so you know, though, yeah, you can pick around a vector. You can pick around a point. The around plane one that Andrew was showing is pretty cool because you can just do global planes and stuff of that nature. You can just kind of pick, and then the big one, like, again, you can go either side, positive side, negative side, outside, between, or at that particular location. And when you do an out location with any of this, you basically just go pick a location from the screen, and then there's this tolerance to say whether that's going to be in there or not. So that's just some good stuff. So, but before I go on to just my regular stuff, no, I don't want to do that yet. I wanted to show this Mesh Control and Explorer. Again, this is super hidden functionality. Again, I don't want to call it hidden. The reason it was hidden is because we coded it during COVID. So nobody, so yeah. I mean, so nobody, yeah, we COVIDed it. So basically, what you could do is you could turn on this Explore Mesh Control, and it brings up this entirely different dialog box. And we added this for 2020, 2021.1 and 2020. It's either 2020.1 and 2020.2 or not. For all of you folks who've had to try to non-manifold add 3,000 surfaces together, and then you get the one problem where it says, surface facets do not exist on the surface, and next thing you know, your whole geometry is corrupted. Well, what if you didn't have to do that to some extent? What if you could just, hey, find me the paired edges. Actually, that's the free edges. Show me unpaired free edges that are adjacent to other edges. This is the big one here. This will basically show you places where lines are adjacent, curves are adjacent with each other, or they're coincident with one another. They're along the same, you can think that they're along the same path, but they have different endpoints. What you can do once you've done that is you can just come in here and you can just say, I want to imprint these points, all these points, for all these. And now you see, if I try that again, hey, there's nothing to show. All right. Now, why is that good? Because we added this too around the same time, which is mesh sizing propagation options. Obviously, if you've been using Femap for a long time and you just tried, if you just tried to mesh two surfaces that were next to each other, even if they had matching endpoints and that type of thing, when you tried to update the one, it just wouldn't do anything to the other one. It would not propagate, typically. Now, what you can do now, especially if you have mapped meshes, like you might have in a ship, or a lot of other structures, is you can just say, okay here. And then I can say, hey, show me the edges that are paired by mapping and proximity. So now I can see them all. Okay, look at that. Again, these are the ones that are unpaired. So those are essentially your free edges. So we know if it's free edge or if it's a paired edge. All right. Now, why does that matter? If I come in the mesh surface, do select all, and put some mapped meshing on these. I'm just going to do select all. All right. Now, again, what I was talking about here was if I increase this now, you can see it's doing all that. None of this is a non-manifold added together. None of it's even, some of the surfaces are stitched together, sure. But in terms of like bay to bay, like, nope. Like that's, there are things going on here.
You could like.
You theoretically don't have to non-manifold add so long as everything is touching or within the tolerance and all the curves are matched at the ends. And then so is that what you mean? Yes. Yeah. Yes.
No free edges now.
No, there shouldn't be. There shouldn't be. You can set it. No. You don't have to do anything. It just knows.
But you can check that and reverse it again.
Sure. Sorry. Yeah, of course. Sorry, I didn't quite understand what you meant. So yeah, at any time you can just turn on element direction, like, show me my normal vectors. Okay, so some of these are obviously going the wrong direction or a different direction. So then what we have, obviously, just so everybody, we have this, and we have orientation normal, and then you can just do them by surface. Yep. And then again, we can just reverse the normals. We can say, you also have an all normals outward, all inward, based on something that you specify, away from a location towards a location. You just have a bunch of things that you can do in terms of that. So now, if you wanted to, we could have also used modify, update elements, update other surface normal, and that would have just switched these guys surface normals as well. So basically, just reverse that surface normal. Yeah, you would have to remesh, but theoretically, what we should be able to do now is just, add a thing, and that should have flipped them around. So, it's proof is in the pudding.
Demo choice.
Bold demo choice, yes, but we've never been afraid to demo stuff, especially to an audience of this nature. So, So anyways, so again, you can do that. You can do things. You can do all sorts of things. Again, the whole key here is to put mapped meshes on here in order for it to propagate everywhere. So just, this is really how it works. Now, let's just say while I'm in here and we wanted to do some, let's just say we wanted to do some localized remeshing. No longer ever, and I mean ever, come into this mesh remesh command. We should remove it. It should be strucken from the record forever because it's old, super old technology. If you want to do any of this type of stuff, you want to come in here to editing. So you want to do mesh editing. So something like element refine. We can do individuals. Well, here, why don't we? Why don't we just start at the beginning here? Why don't we just do some individual splits real quick? We'll just pick a couple elements. Okay, got that one, and then we'll go back up to here. We'll go mesh, and again, where this stuff should probably be is in the toolbox now, but it's not quite made it there yet. But then here you can actually move the, you can moves around. You can make it, and again, this was stuff that we got from our ship build, like a lot of our shipbuilder folks, like this is the stuff they wanted to do that type of thing. All right, now that's great. That's all well and good, but why do that? Why do that when you can just do this? When you can do, I mean, that's if you need to be very precise, you can do that. But why do that when you can do element refine, and you can just start dragging and automatically creating. No, I'm painting. Yeah. I got the back there, if I didn't want that, I could actually now go in there. I could actually come in here and go to remove, and I can, I can still do, I think I can still do shifts and everything. Actually, I don't know if, yeah, it should work. Does it work? No, I don't, it does not, but I could also front pick. That doesn't matter. But let's say I got a bunch that I didn't want. You can just kill this. Nothing's happened yet. You're perfectly fine. You can go either to 4 or you can go to 9 if you need super refinement. If you want to go crazy, let's go back into here. If I just want to do real, kind of, hey, I can do that and get that type of stuff.
When did this painting come in?
4 years ago?
No. Oh, more. A while. Yeah. So
but it's not committed. It's just showing
Yeah.
where it's going to
Yeah.
do it, and
Yeah.
then you
Yeah.
hit the commit button.
Yeah.
No, I'm seeing that he just showed that it wasn't.
Yeah. Oh, there's also, what it's also got? It's also got fun things like grow and shrink. There you go. Like boom and boom. So okay.
I like the 9 better.
Yeah. Well, whatever. So just hey. So let's just say okay, and now that's committed to there. And then
Any
yeah.
loads on the elements
Yes.
get split
Yep.
on the elements.
It all
any
gets-
composite
it's all done.
directions get propagated. Constraints would actually get split and propagated.
Are those nodes being pushed to the surface? It's not just splitting the elements.
If there's a surface geometry there, then they're going to put.
Okay, so
Yes.
those are going to surface.
Yeah.
But you don't have to have.
Yeah, but if you
Yeah.
don't have a surface.
Yeah.
they're-
Yeah.
You gotta let
Yeah.
it see
Yeah, but if
FBA.
they're
Yeah.
attached to a surface, they'll
Yes.
push themselves.
Yes.
And they get
Yes.
reassociated too.
Yes.
So-
Reassociated everything like that.
You have a R-spline option project the circle in there. In other words, can you go in and subdivide and then it'll put an R-spline in there?
Nah,
We-
these
well-
are actually, these are connected.
Yeah, these are
They're not-
connected nodes. This is so much better than an R-spline in almost everybody's mind.
Okay.
But if you did have a mismatched mesh, we do have the ability to create an R-spline in Femap. It's rather manual, but if they're in your model, we will read them in, and then you can reuse them, and we'll spit them back out. And that's part of the reason we did the R bar and the R rod, because it was in so many models. So just yeah, I got you. So, one of the other things that was in here, and this is not actually that's I know it's not going to work because they're not. Oh no, they're connected. What am I saying? So if I go to editing and I use the edge split, hopefully everybody knows about this one. This one's really cool. You basically can just, like this is, this has been in here quite some time, but you can even like come around a corner like this. Oops, sorry. Well, here, I'll just do it once. And it just splits them all the way down the line. And again, it's just purely doing that based on proximity because it's just going connected element to connected element.
You can limit it.
Yes,
Yeah.
yeah. Yep, it'll do the little. Yep.
Do the triangles.
Yep.
Bring it into the
Uh-huh.
system.
You can do this, like you can either, again, though, you could even like go like if you do the multiple guy here, you can like do those. And if you really wanted to, you could do these at the same time. Let's just say we wanted to triple down on these. And what that'll do, this will also, but between those nodes, it will it'll split any element associated with those two nodes. So if it's two nodes of a line element, it'll split that. If it's two nodes of a hex element, whatever, if it can be split, if it's an element that can be split in a normal way, this will do it. If you have like a mapped mesh of any kind. Okay. All right. Let's just, while we're showing the cool stuff, again, a little bit kind of a ship poly type thing. Hopefully everybody saw that we did mesh on mesh. So now we have the ability. Let's just say somebody hands you a model that has no geometry. So you can come in here and go mesh on mesh. Just pick all these. This takes the existing mesh, the existing shell mesh in this point. And let's just divide that by 2. And we'll just say, okay. And what you're going to do is it's going to refine that. But it didn't just refine shell elements. It also refined my line elements everywhere and kept them in the correct orientation with the correct offsets and all that other good stuff. So, if you just wanted to do, and you don't have to do a whole thing like this. I mean, if I just wanted to do a portion, I could. Actually, why don't I leave it like this, and I'll just. Yes, unrefined. Yeah, in fact, here, why don't we do that? This one's probably a better one for that because this is probably a little refined. This leading edge here. So what we're going to do is we're going to do mesh on mesh, and we're just going to pick this by property. Oops, sorry. Oop. And I'm just going to pick this right here. Make sure I got the ones I want. Yep. And what I can do is I could just make this like point. Actually, make it 1. Okay. I'm just going to say okay. Well, I think I wanted to make it 3. Okay. That's all right. That's good. But what you're going to see is it's going to, around the edges, it still remains connected. And then everything is done, so it just did an unrefinement towards the middle. Okay? And no geometry involved here. That's just the mesh.
It's like if you have like a rigid connected, like a bolt.
Well, what it will do, no, it can't do that yet. What it can do though is let's just say, well, that's no, it can't work like that yet. But what we should be able to do is just theoretically put in hard points that it could then follow. Because the body mesher, everything I'm using here is what we call the body mesher, and it's what we got from CD Adapco from the Star Mesher people. Okay, so the mesh bodies command and the mesh on mesh command are essentially the same mesher in the background. One just starts with geometry, and the other one starts with mesh. In both cases, it does its meshing on the facets, and whether those facets are geometric facets or element facets, it doesn't matter. But once it has that those facets, that tessellation that it needs, it can essentially then just mesh over top of it with triangles or quads. So, and then you can even use it to mesh. Like let's say you have a real pain in the neck piece of solid geometry and you want to TEP mesh it. instead of using our geometry preparation command, you can now just use the body mesher instead, and it just goes over all any internal curves or anything like that. So when you're using mesh bodies, that now does follow our mesh hard points. So if you put them into the mesh, it should take care of them. I just don't think we did it for mesh on mesh yet. So
Are you talking about mesh points?
yes, mesh hard points. Yes. Yeah. So, oh, well, even that. Does everybody know we have a mesh hard point editor now? I mean, so just, here, so you can basically just have, and you can put it at coordinates on points on nodes. If you put them in a particular, format, you can load them from a file. You can send these to Excel, update them, send them back. You have so you can do a number of things of that nature. Okay. So go ahead.
Surfaces for a bit. How accurate are the tolerances of the surface?
You actually type in a tolerance.
Yeah, you
but it's,
type in
the hardest thing is getting the normals right on the surface, because if it's a mesh, it's gonna be, it is severely faceted. You can
Yep.
get a halfway decent surface, as long as it's not too great.
Yeah, here. Why don't we just, well, here, actually, that's two disconnected things. That's never going to work. Actually, that would probably give us a really funny thing, but, let's not do that. But, we can just, why don't we delete the mesh or, but you actually have a tolerance here, and you have an angle tolerance that you can use, even a linear cutoff length.
Yeah, mesh on mesh work.
Oh, okay, good. All right, cool. All right. I didn't know we implemented that. Yeah. Okay. Okay. Yeah. All right. So, okay. Somebody did it.
So the
Okay.
mesh point editor, one of the things I API was that we did combine is vector for lines that would interest I'm like,
You know what? And before I forget, let me show you the FiberSim thing that we were going to talk about earlier, because just I don't want to miss that part, because it's kind of interesting stuff. I just have to. Oh, I got all these stinking directories now. All right, hold on. There we go. Hold on. Layup. Where's the layup go there? Oh, come on, you stinker. Okay. Hold on. There we are. There we go. All right. So let's just imagine we have something like this. Let me just close some of this stuff before we get into that. And I'm going to open up that layup builder that Andrew was showing off earlier today. I'm going to put it down here at the bottom just so we can see. A lot of times this stuff comes in kind of wide. Again, Andrew showed you all the making a new layup stack, loading from layups, etc. But we're going to do an attached composites HDF5 file. Okay. So, and again, that's just this option down here. You just pick this guy, and then this is an HDF5 file that came from FiberSim. Detecting the units, I just it's a demo. I know it's no. So basically, what it does is you just need to make sure that you're in the same general spatial space. If you're way down small, in like nowhere near the size of your actual mesh, then it's not going to work right, because it works on proximity to a certain extent. So okay, we're done reviewing that. Got it. So now we can see what we brought into here. So Greg, it's funny. Here's your P's from that maybe, but those are components. But that came in from FiberSim. We don't do anything with that data. We don't do anything with that layer data. We just have it here. So if somebody wants to know, like think in FiberSim, they can do it from in here. Okay. So instead of having to pick all this stuff and set all this stuff, you can just see from composite HDF5. That's where we're getting it. That's where we're getting these values. That's where we're getting a direction from. So all that information is coming from the file that we just read in. And right now we're attached to the file. You can think of the way that we can attach the results. We're attached to the file right now. We haven't really brought in any of the data yet. Well, not actually, we kind of never do. But once this is all set up, if you wanted to, yeah, here's where you could make your global plies. Auto create them. Okay. You know, now they even have their names, which are based on the component in the layer. Actually, they're based on the layer there. But again, that's just coming. This is all just data that came from FiberSim. I think if you have if you type your own title here, that'll be transferred into your global plies. Now,
What do you mean when you say it's attached to the?
Yeah, but
we're sitting on top of the file.
We're just
the
talking
file-
to the file, we're not
Yeah,
internalizing.
yeah.
Okay, okay.
We're
I-
just
Doesn't-
sorry.
Your file
Yeah.
doesn't change.
Yeah.
We're reading what FiberSim says the laminate definition is, and we're just using it whole from.
Yes.
Okay, okay,
Yes.
I got it.
Yes. Yep.
So if I updated that and opened this model again, is it still referencing that same HD5 file? And it would be different the next time, like if I edited the
I don't know
HD5.
if it auto updates or not.
You would want to reattach it for sure. Yeah,
Okay.
absolutely. So, well, actually, you probably would not have to actually reattach it. It would know, but it would be using the new data, but you would have to make your layups again. You'd have to make your layups and properties again. Yes. So,
Okay.
so here you go. So then again, you can show the component if you want, the whole thing. You can just show the outline of the component, or if you want, you can show the fiber direction. And again, if you come in here, check out your fiber direction, you can kind of see what's going on all over your model. All right. Again, all this data is we're just getting it from the FiberSim file. We have not, but we're not beholden to it at all. We can now do whatever we want with this information. And again, we're doing the next parts here. So Femap is now doing this part. It's automatically selecting the mesh from the composite's HDF5 ply input. Okay. I just know I want to do it on the whole model, just so we see what happens. And now you can see my entity selection has been done for me. And again, here's where we can just say, oh, yep, that ply is going to be on all those elements. That ply is going to only be on those elements. That, and you can kind of see what's going on. So right now they're associated with those. All right.
If you clean up the element zone.
Yeah, you can change them to your heart's content. Yeah, you can do whatever you want, but you're kind of missing the point though when you do that, unless you're trying to like align with a particular like
Usually
break
when-
line.
I was
Yeah,
just thinking,
yeah.
Where's it from?
Sure. Yeah.
If you technically don't have the data there.
It's
Extrapolate from
it's going to extrapolate.
Okay.
Yeah. So just you don't have to even worry about that. I guess if you didn't have HDF5 down the middle here, like down this whole section, this maybe goes back to your stacking on top of multiple HDF5 files from FiberSim to try to build an overall fly stack up. That might be where I kind of understand what you're talking about. Now, again, we just thought most people would just have them all in one file, but I can understand, you might want to change it.
FiberSim data, a lot of people.
Yep. Gotcha. Okay. So, all right. So, again, we can hit our, yep, we got no errors. Now here. Now this is the big difference. So, all right. So because this is kind of a fine mesh, it just made me 1,179 properties and layups for my 1,311 elements like that. None of these properties existed before. Sorry, I shouldn't have had it obfuscated from you. But here, and then you can kind of just see where it goes. All right. Now, you can see in a lot of cases, because we had it be as much of a hammer as possible and make as many as possible without trying to restrict what it did at all, it made quite a few properties and materials. Let's just undo for a second though, and this is where we can come back into here and come over to our layup creation. All right, and here you can see, look everybody, you can see our randomized property colors, and if you wanted to do the offset bottom surface, you can turn those on now. And then you just can have the angle consolidation strategy of like whatever you might want. We'll just leave it at the 5. And then you can also have a thickness consolidation strategy. You can do it with materials. You know, you can do there's a bunch of things in here that you can do. Okay.
You had multiple HDF files, can you stack those?
No, we can't yet, but Andrew only told us of that, 20 minutes ago. So,
So maybe by next
Give me
week.
some time.
if you could give us some time.
Andrew, with a
Yeah.
stack file and a layup ID distinct, or they could start over again at the 100.
Okay.
I would have to.
Right now, we use that to determine stacking. That's what FiberSim does. It's a wrong.
But
If they get reused, it's gonna be.
I think there are gonna be individual layups, but I don't want the idea.
Okay.
But you can see instead of it making me 1,100 properties, it only made me 700 just because I opened up that angle tolerance. So this might be something a little bit more along the lines of what someone might actually want for a finite element model. It all depends though, just say, okay, and again, now you can really see like, that it did its best, just where it could, it really tried to kind of figure out, best it could, where it could do its consolidations. So at least you got a couple elements here and there.
And it really layups, look at the.
Oh, well, yeah, hold on. Now you know what we should be able to do from here?
Yep.
You got it now, but you can do it from here. So, yeah, hey. But then, yeah, there's your thicknesses, there's the angles it put in, here's, if it could, it used the global ply ID that we did make automatically from there. So, and theoretically, every ply that, like in this model, now has a global ply. It's just, if you were trying to copy them in, you might, no, actually, that should have worked just fine too. So, and again. Okay.
And that angle is relative to what? To what coordinate system? That's the material.
From FiberSim actually gives us for every element it gives you.
Yeah.
You know what the base is. That's coming from FiberSim.
Okay.
Yes,
okay,
yes.
okay.
And it's set in Femap, you turn on the material angle, we'll see what it told us to do.
Oops. I do it. Use it part.
That came in from FiberSim
Yeah,
as well.
yeah, that data came in from FiberSim. So it's relative to that. Okay. All right. So again, it's really neat functionality. There's obviously this is first implementation of it. We obviously got some feedback from it before today, and now today even more. So it certainly is something we can check out.
And Andy, not to be the jerk, but bends would be really nice. Folders, bends, have it all stick it in a single folder so you can.
Don't start with me with those. I want those too, but everybody, but the different powers that be back at the office want true assembly modeling without bins. I think bins would work, but but they're two entirely different things. So just, bins, to me, bins are simple. Bins, we already have bins.
We do have this.
We have bins in studies. Yes,
Yeah.
as analysis studies. Yes, completely. I understand the idea of bins. And everybody heard it here again. All the people want is bins. I don't want the rest of your nonsense. So just, we can call them buckets.
Can we call them buckets? not
Yes,
bins?
yes, we can call them buckets. Yeah, so just absolutely. That's what we really do call them, buckets.
It just needs to be a preference, but bin, buckets,
Yeah, bins or buckets.
folders.
It just depends on what icon you get. But
Bag.
yeah,
Bags.
bag.
Bags.
But okay, well, yeah, Greg, I just want to make sure I showed you that.
Thank you very much.
I thought you might be getting a little antsy to,
There you go. No, that's
might have to
perfect.
go
That's
somewhere.
what-
Yeah, so, again, just, I know I was showing this earlier, just because I was showing, but I was kind of using it for a different thing. Just know now that too, if you have a surface that you can put a mapped mesh on, and you have like a hex mesh like this, you can just come in here. You know, here, let's just get like an overall size. Yeah, okay, that's fine. You can just come, like, if it can be mapped mesh, it'll just update and put a map mesh on there. You know, again, if you were hex meshing before with previous versions of Femap, when you were doing that, if you did not get every single curve needed to update it all at the same time, it just wasn't going to work. But along with that, here, I'll go back in here. This actually shows a different thing. Is we actually have, hey, which surfaces have mapped approaches on them, and which surfaces are linked for like hex meshing. So sometimes you might not know that. So sometimes the direction that something's being hex meshed was not obvious. Okay, so what you can do is come in here to the Mesh Control Explorer, and you can kind of see, like, show me the match surfaces, show me which surfaces have a mapped approach on them. You know, and then I already showed you the rest of it. So this actually has multiple tools for multiple different types of meshing, but all of it relies on this mesh proximity options. So you do need to have this specified correctly. And again, if you want to, you can change your edge pairing tolerance, so you can really loosen it up, or you can tighten it up, whatever you might want to do. But then if you just want Femap to work the old way, you can just turn this off, and all that functionality goes away. You know, so but that's fine. If you need Femap to work the old way for some reason, you can just come in here, turn that off, and then none of the propagation will happen. So that's just something to remember. Now, one other thing too, just you know, again, this was added somewhat lately, so I think most people might have seen it in this. What is this? It's this hex mesh bodies command. Basically, you don't have to subdivide. It just uses a target size, and then just fills the volume with as many hexes and wedges as possible. Then fills the rest with pyramids and tets. And unfortunately, I mean, we probably could put something in where it would remove the pyramids and only put tets. You wouldn't quite be getting the same thing, but it would probably work enough. You know, just in case your solver does not support pyramids. But I think most do now, including MSC Nastran. So, which was a relatively new thing. So, but the nice part about this is I just missed that assembly, and I didn't have to split the curves. I didn't have to do anything like that. I basically I'm just able to now check coincident nodes, methods, and solids. And what you can actually see is it just knew to match the nodes on both sides. On everywhere where it knew was an assembly, from based on proximity, it just decided to match the nodes there. So not decided. I mean, that's the way it works. So theoretically, you can mesh whole assemblies with a hex dominant mesh and have it all be combined, so long as, you know, think about if you were going to do like an automatic connection on an assembly, something of that nature. And just so you can kind of see, yeah, we're just gonna get out of here. Let me come over here just so you can see what's going on. So let's just turn off all my bricks and all my wedges. Here we go. And turn off my geometry too. Oops. Okay. I hit the button I wanted added, and I hit it all the time by accident. But essentially, yeah. So essentially, those are those are the only TETs, and those are the pyramids that it put in to that model. And again, this was version 1.2 of this semi or hex dominant mesher that we got from another piece of Siemens, the folks that write Flow EFD.
What's that saying, 95%?
And yeah, 90, yeah, so this mesh is 96% hex elements by volume, and we meshed a 3-part assembly without having to subdivide it at all.
Are
So
there ways to put in, mesh approach, like,
no,
for your lug to do?
no, I mean,
Well, you can do smaller elements. If you tighten it up, you
yeah.
can get like better round holes and stuff.
Yeah.
You can juice it down in that area and you'll get a better mesh, and that automatic connection will make sure it's connected. So you can do somewhat, but you
Yeah.
can't be guaranteed.
Yeah, you can't be guaranteed things because it's basically designed to
See, automatic.
be automatic. Yeah. But the other thing you can do with both the body mesher and, well, again, I don't want to forget that. Sorry, let me go back to my. Okay, sorry, again, we had these, I had multiple of these. Show me what you did in the last 5 years things. So, there we go. Here we go. So just so you do know the body mesher. Again, I'm not going to harp on this very much because I think people have seen it, but mesh bodies, boom, boom, boom. You can see we have mesh points on the middle one, and we have both mesh points and constrained surfaces and loaded surfaces. So if I just say, okay, again, I didn't have to do any mesh sizing. It's just going to try to use this target element size. If you want to, you can have it associate to all geometry. You can have it do required geometry only, but that's probably the way it works best. So basically, well, I'll show you. It's fine. Required geometry only. And then you have, like, if you want to, how many points you want to put around a circle. There's some other element sizing factors. There's some other things in here. Like if you were going to use this for TET meshing, there's some options. There are some mesh quality things that'll even improve this in curvature and proximity. Again, this is the same mesher as the mesh on mesh command. It's just operating on geometry. But again, it's not even really operating on geometry. It's operating on the facets of this geometry. So what you're going to see, our initial implementation of this did not include supporting mesh points. That's since been added. So, sorry. So yeah, we have, okay. So now, just so everybody knows, if I come here, all those internal curves were completely ignored. It just meshed right over them. It didn't care at all. So, and this thing makes just absolutely gorgeous shell meshes. And then from gorgeous shell meshes, especially triangle meshes, it makes it then just takes those high quality triangles, sends it over to our TET mesher, and then it makes high quality TETs. So, but then you can see over here, if I just turn off my loads and boundary conditions here, you can see that it followed there because it knew it needed to, because those were loaded and those were those were constrained, and then and there you go, and then it follows the mesh points. So, and you can combine, using the body mesher and then using the mesh on mesh. You can do whatever you want in terms of that. So, okay. So, all right. So that was half the tips and tricks session, was just showing you what's new in the past couple of years. And some of these, again, were iterative. So essentially, it worked. We got it working, then we added to it, and then we added to it some more. So, so those are some things. This Mesh Control Explorer is fantastic. It makes life so much easier if you don't need to non-manifold out everything together. And the other thing with the Mesh Control Explorer with the propagation stuff is that other thing I showed you with that replace, the edge replace. You can actually just use that edge replace to get everything lined up and not even have the non-manifold added at the end as well. So it's just one more of those, especially with some of the, so you can do even stuff where you could even do the partial and then use this tool, you know, this show unpaired free edges that are adjacent to one another, then do the imprint points on that. So there's just a lot you can do now that you couldn't do even 5 years ago. So, you know, okay. All right. Well, we've actually gotten in the roundtable time, so why don't I just show you something else? I was just going to show. I have one. I just have one brief. I have 3 slides. Sorry. I just wanted to show you the things we're working on, just because, and these are just based on some stuff, bunch of stuff that we've heard lately. Where are we at? Okay, here we are. Okay. There's just some kind of high level type of stuff that we're working on. So these are things that have already started or are very likely to be done in the short term. The first, the biggest effort that is left to getting everything the unified graphics architecture is, of course, getting elements in there, and that's in process. We hope that's going to be done by the end of the year. So we are going to have a 3rd release this year. It's going to be called 2412. Okay, so hopefully the elements will be all in there. So then it'll just be kind of minor things, kind of that we'll just pick off time after time. But once the elements are in there, that should be huge. Add support, and I'm just going to say this, to some degree, for products created by Zona Technologies. Now, just so everybody knows, Siemens purchased Zona. So, you know, and that just went through this year. So, and they're a big aero elasticity, high level aero elasticity, kind of a second, like almost the next, like a order, I don't want to say an order of magnitude higher level than like what's in Nastran, but just different technology. And they also have supersonic technology and hypersonic technology, which you cannot model correctly with the one that is currently in Nastran. One of the things that they will do is reincorporate the supersonic stuff that was in MSE Nastran. That's actually always been in the code. We just weren't allowed to license it because it was owned by Zona. But now Siemens owns Zona, and we've actually been tasked with doing stuff for them. So, yep.
So we had an integration in NEI with the client for a long time.
Yep.
So,
Oh.
I think it's pretty simple. It just involves like a modal analysis.
Well, and I understand what you're talking about, and we've talked to a few customers, and they only seem to really be using the Flutter parts of it.
Yeah.
In a lot of cases, but we're really looking for kind of outliers who are using stuff that's beyond their Flutter or beyond their static arrow or beyond the type of arrow where they can actually use airfoils. They can actually model airfoils, you know, just kind of based on profiles. So, you know, that's so, but if anybody here in the room is using Zona, come talk to us. We'd love to talk to you. Just, you know, because we'd really like to find out exactly which pieces you are using, because we need to know what to support first. That's just critical.
One of the basic things though that could be tricky is that you have to multiply the eigenvector times the mass in a fitness matrix, I think. I'm just, it's been 25 years since I've looked at it.
Yeah, but why, Dave? We're just creating a file to send to the solver. So I mean, yeah, the Zona guys already do that. So yeah, no, but I
thought they were going to do with NX.
No, oh no. This is Femap related. You know, just you know. So, and we're looking into, again. We're just starting to scope this out. Okay. A couple things.
Would you see Zona like being part of like the coding for that?
Licensing, yeah, you don't know where that's going.
Who knows? It's also very new. What, it closed at the beginning of April, I think, or end of March, whenever it was. So it's still really kind of brand new to us even. We've only we've only talked to the folks a couple of times so far. Okay. The next one here is the ability to store quantities generated by solvers, which are specifically for use with like charting. So, the idea of storing results functions, results tables, things like that come from the solver that you'd want to chart. This is just certainly something. And again, the idea would be to store them with the analysis study. So that if you deleted it, you could at least have an option whether you wanted those to be deleted along with it, or kind of remain around. This was something dumb that we did when we went to the function table editor and we didn't give them different IDs. That was just stupid, but we think we have ways around that now. We can just take the old ones and make them new ones. One that is near and dear to my heart would be to have Femap appear in dark mode or any other UI color mode than bright in your face. That's certainly one. I mean, I run everything in dark mode at this point, so hey. Streamline. I'm just going to skip to this next one. Streamline post-processing for laminates where possible. Again, this is where we could use some suggestions, so we'd like to hear some if anybody has some ideas. And again, add support for lesser used entries in Nastran solvers. I mean, we support Nastran to a really high level at this point, but there's still a few things in there that we don't do. And the other one here is expand. We have the use of, I didn't even mention computed vectors today. I did mention them maybe a little bit. They were added for 2301. Essentially, we can automatically make a bunch of standard vectors now, but they can also be user defined. We're looking for more quantities to be able to automatically calculate for people, just so they don't have to do them with APIs, that sort of thing. But the other half of this is really to perform more advanced types of calculations, whether it's based on the model's characteristics or something provided by the user. Like, hey, show me a bunch of stuff about the quantities on this particular panel. They don't have to have it defined. They can just pick it and just be calculated and spit out something like that.
Max shear flow in a panel,
Yeah.
panel buckling,
These
like that.
These type of things. So we already have the computed vectors stuff that can do it on the fly for you. Store it or do it on the fly. Store it for a second, and then. But it's all in Femap now. In the computed vectors. You don't have to access it via the API. Some other stuff just on the Prudential projects. We know everybody doing system level modeling, real system level modeling, uses include files. So a much better include file manager. This project we also think could really lead to having a more streamlined, better overall support for super elements. You can kind of have them going hand in hand. And here's my support for assemblies argument. What this means is still very much up in the air. Could be buckets of geometric entities or resemble support for assemblies in a CAD system. So there, I vote for buckets. But assemblies, obviously buckets could be of properties of layups, etc. We have leveraged a lot of this, and maybe again this might be some hidden functionality that we might be able to show. Just greater use of the tools, Parasolid tools used by NXCAD, Solid Edge, and other Parasolid-based CAD products to perform like on-the-fly updates to geometry, and also update their associated mesh. Along with this is maybe just put a global checkbox in, and this is I'm never going to promise this, but basically put in some sort of global check mark where if I do a geometry command, try to update my mesh. So instead of having to put a washer on via the toolbox, you could put a washer on via the command, the menu, something like that. You can think of it that way, But a lot of this is already most of it's already in the toolbox. You know, so, and honestly, that's where we're pointing people anyways. And then implementation of mesh morphing techniques, you know, to change overall dimensions and or shape, but kind of keep would do that without changing the underlying number of elements or the numbering of those elements underneath, you know, that very, very people who are only working with basically finite elements, no geometry. I mean, that would be, that's for, and I just put this one down at the bottom just because it's been on the list since I started Femap.